Good evening. The topic that we are going to talk about is a feature that is available in Windows 10 and 11 devices that most people doesn't know about. Windows devices can authenticate themselves through a series of different components that are already embedded into the operating system. It means that the device will prove its identity the same way a user does when signing into Windows or any other application. We're going to discuss these components in the next slides. So the first component we are going to talk about is DSREG. This stands for Device Registration Service and is a component of Windows OS that is responsible for the device registration and management in the context of Azure Active Directory. This component is an orchestrator that facilitates the registration process with Azure AD that helps to establish the device identity. So this image is the process to join Azure AD. Um, and during this process, we are going to have, it will be created a pair of keys that are called session keys. These keys are used to encrypt and decrypt some data that we will discuss more about in the next slides. And these keys are protected by a component called TPM. But what is TPM? So TPM is going to be explained by my partner in the next slide.
The TPM, or Trusted Platform Module, is a hardware-based security component that is designed to provide a secure foundation for various security-related functions in computing devices, such as laptops, desktops, servers, and IoT devices. It is a microcontroller chip that is typically soldered to the motherboard of a computer, and it offers a wide range of security features and capabilities. Here we can see a picture of the TPM chip to see how small it is compared to the rest of the components of the computer. The TPM includes a special feature called secret storage, where the system can save sensitive data like encryption keys, passwords, and digital certificates. This allows for the protection of sensitive data and cryptographic keys from software-based attacks. The TPM is not a storage component. Instead of that, it will use Windows and physical resources to store the protected components in a secure container. The TPM can respond to tampering attacks by invalidating certain keys or certificates, locking down the system, or starting other security protocols to protect data and system integrity. Containing with the device registration, unless the device joined Azure AD, it will have an identity, and this identity will or may be used to protect access to resources. For example, we can use conditional access feature in Azure AD to request the device identity to allow access to specific or any application. Here we can see a screenshot of the conditional access policy creation screen and containing if the device is unable to authenticate, it will be treated as an unknown device, and access will be blocked. Here we can see the error screen that Microsoft shows if the device isn't registered into Azure AD.
To prove its identity, the device, once it's joined to Azure AD, it will a token called primary refresh token. A token is simple and a specific type of file that contains text either in XML or JSON format, providing some important information about the entity that it's authenticated. In this, the PRT contains device ID that will be presented to Azure, and Azure will check the ID and find it in the databases to make sure the device is who is aimed to be. When its identity confirmed, the conditional access policies will be applied to determine whether the user is allowed to access specific resource from the devices or it should be blocked. We have some Azure ID devices, as we can see in the image. We have several devices that are joined and registered in Azure ID. These devices can be incorporated on devices or personal devices. Some of them are also managed managed by Intune, which is a mobile manager that allows to secure the devices and set complaints policies. These policies can be used to allow or deny access to resources in Azure AD. For example, if the device doesn't comply with the policy, then access is denied. Having these devices registered in Azure AD is what allows to have a secure and seamless sign-on experience.
Good night, everyone. Thank you so much for the attention. So, keeping with the topic, what makes this interaction possible that we have been talking about? So there are some components in the Windows OS that makes this interaction possible. The user experience in an Azure AD joint device is what we call single sign-on. The user is not required to enter the credentials when trying to access any corporate application. That means when you are accessing an application, instead of you putting your credentials, like your username and password, instead of that, you just get access to the application. And that happens behind the scenes, so the user doesn't even notice that. The user and the device identity is contained in the PRT, or the primary refresh token that we mentioned before, and this token is shared with applications and browsers using the following components. First one, we have the web account manager. The one is what we call a broker. So it's a default token broker in Windows 10. So a broker is pretty much the one that will be handling this token in the interactions between the user and applications. So the one also provides a plugin framework that identity providers can build on and enable SSO on their applications relying on that identity provider. And when we say SSO, we are talking about the single sign-on experience. So the other component, the Microsoft Entra Cloud App plugin, is a plugin built on the Cloud App framework that is already embedded in the operating system that verifies the user credentials with Microsoft Entra ID during the Windows signing. And we have the Microsoft Entra One plugin, which is another plugin built in the operating system as well. It is on the One framework that enables SSL2 applications that rely on Microsoft Entra ID for authentication. And I'm going to explain that a little bit better later. So when the user enters the password to sign into Windows in the what we call the logon user interface, right? The UI or user interface passes the credentials in an authentication buffer to the LSA. So LSA is the local security authority in Windows. So it's pretty much anytime you sign to Windows, the LSA is the one that will be handling the credentials. And it is a crucial component of the operating system responsible for managing security policies and authentication processes. It plays a central role in ensuring the security and integrity of the Windows systems. Now we also have the Microsoft, the Cloud App plugin. We already mentioned that before. So pretty much during the Windows signing, the Microsoft Entra Cloud App plugin, it requests a PRT from Microsoft Entra ID using the credentials provided by the user. It also caches the PRT to enable cache signing when the user doesn't have access to an internet connection. So just for you to know, in Windows, when you put your credentials, those credentials are going to be cached for 10 days, which means that if you don't, even if you don't have an internet connection, you can enter with the same credentials during those 10 days. We also have the One plugin. So the One plugin, when the user tries to access applications, this One plugin uses the PRT that is already cached in the computer to enable the single sign-on experience on Windows 10 devices. So pretty much the One plugin uses the PRT to request refresh and access tokens for applications that rely on the One for token requests. It also enables single sign-on on browsers by injecting this PRT into the browser request. The browser is on Windows 10 or newer, is supported on Microsoft Edge, Chrome. Well, Chrome, it requires an extension that obviously was created by Microsoft, and also on Mozilla Firefox. Now, did you remember that we mentioned a key before, the session key? So the session key that we mentioned before is encrypted and secured using the DPM. So this is used to prove that the PRT belongs to the machine as a way to secure the authentication. So this is just the flow that it follows. All these are components in the Windows 10 operating system, as we have discussed before. And as you can see, the Cloud App plugin is the one that will be sending the request to Azure AD. Then after the authentication process happens and it is successful, it will send the PRT to the machine and it's going to be stored in the cache, as we have mentioned before. So the next time that you use your work computer, think about all these processes that happens behind the scenes. Thank you so much for the attention. That will be all. Have a great night.